Hello, my name is Minh-Thơ Yoon. This is the presentation for assignment 2 of unit SIT 718 Real World Analytics. Let's begin. In the assignment, we are given a red y dataset with 5 x variables and a single y column for the quality score. The assignment contains 4 parts and 500 data samples are used for the analysis process. In the first part, I apply correlation functions and statistical summary to get an overview of the data. Moving to each column specifically, the quality has a normal distribution with most of data gathered in the mean and median values. Next, citric acid and alcohol columns are right skewed. They are more smaller value than the larger ones. In the pH column, data spread out evenly. I also take note on the mean, max, and quantile range in each column to compare and identify outliers. The next two data columns have some significant values. In chlorides, data is strongly gathered between 0.05 and 0.1. In total sulfur dioxide, there is an outstanding value at 300 mark. It makes the data has a wide range and become unreliable. In the second part of the assignment, I remove all outliers and select for x variable from the dataset. In that, chlorides is not involved into the analysis process. After that, I apply z-score standardizations in all columns to scale the data in similar range. The strength from data also gets verified before performing fitting models. There are 4 fitting models for the strength from dataset. Each model generates 2 output files, which are the statistic file and the output data. The table illustrates the root mean square error and the weight values corresponding to each x variable. I also include the correlation coefficients. In that, all fitting models provide appropriate error with some similarity on the weight value. In the red y dataset, each sample is separate. There is no relation about power function and the order between each sample. So the weight arithmetic mean is the most fitting model. After that, I applied weight arithmetic mean models to generate quality prediction for a new input array. I performed the same analysis and data transformation process. The fitting model results an output file contains new transform data. There is an extra column for predict value. To be able to read the output data, I developed a reverse function and apply it for the whole transform dataset. As a result, after performing weight arithmetic mean models, the prediction for the quality of new y sample is 4 score. It is a middle score in the range of quality from 3 to 8 over 500 sample data. Let's have some discussions on the model result. I gathered some samples for each quality level of the red y and analyze the role of each x variable into y quality. In particular, there are 2 x variables have influence on the taste of the wine. The citric acid with sour taste, like lemons or clam juice, and the chlorides with salty taste. It's more likely that citric acid has more important role. Next, there are 3 chemical characteristics. By looking at the table, total sulfur dioxide with 0 weight values has no significant contribution. On the other hand, it can clearly to see that wine with strong alcohol gets more flavor, and the pH level should be managed in around 3.2 or 3.3. The weight arithmetic mean models provides a general idea for the quality level of the red wine. I am also interested in the new input array. Let's have an investigation. Specifically, it's predicted to be in 4 quality score, which is not an excellent wine. The sample has a high concentration of citric acid, but very low value in pH level and alcohol, smaller than the minimum range. So the new input data may not be considered as a type of red wine. Based on a strong sour taste, it could be a lemon soda. In conclusion, the assignment provides data analysis practice in a well-formatted dataset. In that, weight arithmetic means is the most suitable fitting model applied for separate wine samples. The assignment requires good understanding on the data distribution, data cleaning, and transformation. However, the predictions are the average results. There can be cases which are outside of the general ideas, and it is the limitation of the weight arithmetic means model. The last but not least, the implementation for unit assignments is refers from some learning resource. This is the end of the presentation. Thanks for listening.